if we want to find the nth term of a sequence, we want to find a way to represent that sequence with algebra. First thing to look for is what happens from one number to the next. In this question, we can see that it increases. So it goes up by 9 from 6 to 15. It goes up by 13. And then it goes up by 17. Now this is not the same amount every time, so it's not a linear sequence, it's actually what we call a quadratic sequence. It has a second difference, which is the difference of the differences. From 9 to 13, it goes up by 4, and from 13 to 17, it also goes up by 4. If this is the same, then it is a quadratic sequence, which is what we have here. Now this number helps us find a part of our final answer. We always half this value to tell us how many n squareds we have. In this case, we have 2n squareds. This is going to be the key to the next part of the question. We now need to do our original sequence, so I'll rewrite that out again. 6, 15, 28, and 45. And we are going to subtract our 2n squared sequence. Now the n squared sequence is 1, 4, 9, and 16, and so on. It's all of our squared numbers. So the 2n squared sequence is all of these multiplied by 2. So 2, 8, 18, 32, and so on. So this is the sequence. That's n squared, and that's 2n squared. This is the sequence we're subtracting from our original sequence. So take away 2, 8, 18, and 32. In this case, what we're left with is 4, 7, 10, and 13. Remember, this would continue. Now we've got a linear sequence. This is going to be the remainder of our answer. So as we normally would with any nth term, we see what it goes up by. In this case, it increases by 3 from term to term. So we then have plus 3n. And finally, we see what number would come before the sequence if there was one there. So if it increases by 3 to the right, we decrease by 3 to the left, taking us down to 1. So we put plus 1 on the end, and that is our quadratic nth term.